Okay, for chapter 3, I'm going to have to do most of the sections in 2 videos because there's a lot of concepts and a lot of definitions to explain. I'm going to do that with the first video and then go into example problems after. Uh, Chapter 3 deals with what we call logic, and it deals with statements and logical connectives. And I'm reading straight from the book, so if you want to look at this at the book, that's fine. Advertisements often rely on spoken or written statements that are used to favorably portray the advertised product and form a convincing argument that will persuade us to purchase the product. Some familiar advertising statements are, it keeps going and going and going. Once you pop, you can't stop. Impossible is nothing. And what happens here stays here. In this section, we will learn how to represent statements using logic symbols that may help us better understand the nature of the statement. We will use these symbols throughout the chapter to analyze more complicated statements. All right, now, so what this is all about is logically thinking through truth or non-truth. All right, the history of this, okay, and this might help in terms of your final project. The ancient Greeks were the first people to systematically analyze the way humans think and arrive at conclusions. Aristotle organized the study of logic for the first time in a work called Organum. As a result of work, Aristotle is called the father of logic. The logic from this period called Aristotelian logic. Since Aristotle's time, the study of logic has been continued by other great philosophers and mathematicians. Gottfried Leibniz had a deep conviction that all mathematical and scientific concepts could be derived from logic. As a result, he became the first serious student of symbolic logic. Mathematician Charles Dawkins, better known as Lewis Carroll, incorporated many interesting ideas from logic into his books Alice's Adventure in Wonderland and Through the Looking Glass. All right, now, the language of logic, okay. In reading, writing, and speaking, we use many words such as and, or, and if then to connect thoughts. In logic, we call these words connectives. A judge announces to a convicted offender, I hereby sentence you to 5 months of community service and a fine of $100. In this case, we normally interpret the word and to indicate that both events will take place. That is, the person must perform community service and must also pay a fine. Now, suppose a judge states I sentence you to 6 months in prison or 10 months of community service. In this case, we interpret the connective or as meaning the convicted person must either spend the time in jail or perform community service, but not both. The word or, in this case, is called the exclusive or. When the exclusive or is used, one or the other of the events can take place, but not both. In a statement, a waiter asks, may I interest you in a cup of soup or a sandwich? This question offers 3 possibilities. You may order soup, you may order a sandwich, or you may order both soup and a sandwich. The or in this case is the inclusive or. When the inclusive or is used, one or the other or both events can take place. Okay? Statements of logical connectives and quantifiers. A sentence that can be judged either true or false is called a statement. A sentence that can be judged either true or false is called a statement. Labeling a statement true or false is called assigning a truth value to the statement. Here are some examples. There are 100 inches in a yard. The Empire State Building is in the state of New York. The National Basketball Association team from Portland, Oregon is called the Lakers. Let's look at the first case. There are not 100 inches in a yard. There are 36. So this statement is false. The Empire State Building is in the state of New York, so this statement is true. The National Basketball Association team from Portland is not called the Lakers, they're called the Trailblazers, so it is false. The three sentences discussed above are examples of simple statements because they convey one idea. Sentences combining two or more ideas that can be assigned a truth value are called compound sentences. Sometimes it is necessary to change a statement to its opposite meaning. To do so, we use the negation of a statement. For example, the negation of the statement Emily is at home is Emily is not at home. The negation of a true statement is always a false statement, and the negation of a false statement is always a true statement. We must use special caution when negating statements containing the words all, none, and some. These words are referred to as quantifiers. Consider the statement, all lakes contain fresh water. We know this statement is false because the Great Salt Lake in Utah contains salt water. Now consider the statement, no birds can swim. This statement is also false because at least one bird, the penguins, can swim. Now let's consider statements involving the quantifier some. As in, some students have a driver's license. This statement is true because some students will have a driver's license, some will not. If we want to negate this statement, the negation of this statement must therefore be false. The negation, no students have a driver's license, which is a false statement. Consider the statement, some students do not ride motorcycles. This statement is true because it means at least one student does not ride a motorcycle. The negation of this statement must therefore be false. The negation is all students ride motorcycles. The negation of quantified statements is summarized as below. Form of statement, all are, some are not. None are, some are. Some are, none are. Some are not, all are. The following diagram might help you to consider the statements and their negation. All are can be led to some are not. Some are can be led to none are. Here's an example problem. This example problem says, write the negation of each statement. All right, first of all, letter A is in yellow. All Cocker Spaniels are dogs. The statement, all Cocker Spaniels are dogs, is a true statement and is of the form all are. Referring to the text above, to negate a statement of the form all are, we write a statement of the form some are not. Thus, the negation of the statement, all Cocker Spaniels are dogs, is some Cocker Spaniels are dogs, which is a false statement. Going to letter B, some insects are mammals. The statement, some insects are mammals, is a false statement and is of the form some are. To negate a statement of the form some are, we write a statement of the form none are. Therefore, a false statement would be none of the insects are mammals, which is true. Going to the third one, some days are not Mondays. Because the statement some days are not Monday is a true statement, we have to negate it so that some are not. Therefore, the negation of the statement is some days are not Mondays, which is a false statement. Come to the last one. It says no coins have the image of Abraham Lincoln? Because no coins have the image of Abraham Lincoln is a false statement, the negation of it would be some of the coins have the image of Abraham Lincoln, which is a true statement.